no problem. We can find these pretty easily. I can see, starting out here anyways, that the 99 degree angle and angle C here are vertical, which means angle C is also 99 degrees. But we do need angle B, and I see with the 99 degree angle and angle B, or even you could say angle C, angle C and B, they create a straight line here, which means they are supplementary, which means you could take the 99 degree angle and angle B here. If you were to add them together, you'd get the straight line angle, which is 180 degrees. So to solve this one, all we got to do is one principle of equality by zeroing out the 99. So just minus 99 from both sides. And that'll give us angle B. So in my calculator, I got 180 minus 99. Enter, and it gives me 81 degrees. So this angle here, angle C is 99 degrees, angle B is 81 degrees. Okay, 3 objectives for the day. I can round to the tenths and hundredths, which we'll need. And also I can find the circumference with the radius or diameter of any circle. But then also we should be able to find the radius and diameter from the circumference of any circle as well. So take a minute to copy these down, please. Going over some rounding stuff, you have to be familiar with some of the place values. Okay, so in the past, you've gone over some place values. If you have a decimal, or even if you don't, you could have this place value, and then every 3 place values represents what we call period. The first place value to the left of the decimal is the ones place value. Next would be the tens. And then the hundreds place value. And if you go further than that, sometimes you'll see a comma like this. But the next 3 place values are in the thousands period. So we would say this next one here to the left of hundreds would be just the regular thousands. Now the other 3 here are still thousands, but they're specific types of thousands. So let's see. Yeah, thousands like this. Okay, so this one right here, immediately to the left of the comma would be just regular thousands. But the one just to its left would be the 10,000s. Okay, so we see kind of repeating of what we call the base period. Ones, tens, and hundreds. So the next place value would be 10,000s, and then one to the left would be 100,000s. Now this can continue to the left into the millions, billions, trillions, and so forth. But really we shouldn't be dealing too much with hundreds, tens, ones, or even thousands. Today we're looking at rounding as part of our objective to the tenths or hundredths. So that would be one place value to the right of the decimal, and then one place value to the right of that. Okay. So one place value to the right of the decimal, it's not just tens here, it's tenths. And the TH has to kind of be emphasized a little bit here. And then even to the right of that, again, it's not just hundreds, it's hundredths. All right. Now it's possible we may need even one more place value to the right of hundredths, which would then be thousandths. And hopefully you're kind of seeing a pattern here. If we were to continue to go to the right of this thousands place value, you'd have 10,000ths, 100,000ths, millions, 10 millionths, and then 100 millionths, and so forth. Okay. Now the reason why I'm pointing out thousandths is because when we round to the nearest hundredths, we are looking to the thousandths place value. Okay, so this is what we got to do first. Identify the digit that is to be rounded. So like we said on the objective, we're kind of targeting the tenths or hundredths place value. So that's pretty much where we're targeting, but once we identify that, you can either underline it or circle it. But then we look to the right of that digit. And we see if the number to the right is 5 or more, because if it is, then we add 1 to that target place value. If the number to the right is less than 5, then it's called rounding down, but it just means we keep the digit in the target place value the same. Then after we know whether we're adding 1 or just keeping that target value the same, the target place value the same, then we change all the values to the right of that digit to zeros if there are any. So in other words, if let's say I was to round to the nearest hundredths, and let's say in the hundredths place value, it doesn't really matter what this is, let's say it's a 7. If the number to the right of that 7 in the hundredths place value, which is my target place value where I'm rounding, if it were a 3, then I would keep the 7 the same, and then we pretty much get rid of everything to the right, including here the thousandths place value. Let's say we've changed the scenario a little bit, but let's say the thousandths here let's say it was even just a 5. If this was a 5 in the thousandths, like I have now, then I would need to add 1 to the 7, and then again the 5 would then become essentially a 0. Really, they're just phantom zeros. They're just because we don't have to look at those. Okay, so those go away. We don't have to look at them. And if by chance the place value we're rounding to needs to add 1, but it's a 9, then we know that 9 plus 1 would be 10, so you'd have to carry 1 over to the next place value to the left, which can happen from time to time, so be aware of that. Just know that and I would almost expect for that to happen on the assignment, because math people do that kind of stuff to other people. If you can understand rounding, then estimating these values or rounding them should be pretty easy, but like I said, we're pretty much going to have to round every one of our answers. So, in circles, we have some vocabulary that we have to be familiar with. The center is just the middle of the circle. In other words, it's the same distance from every edge of the circle. So, I don't know if that's exactly the center, but we can kind of say that it is. Meaning this point right here is the same distance to any part of the outer edge. So like this one, it's the same distance as it is from this one, okay? Or even on the red line, assuming that I had done this better. This red line here is the same length as this red line right here, okay? So this green point right here that I've just put on my circle, I'm going to call that my center. And if you somehow found the exact center, then good for you. But I did the best that I could. Diameter is another vocabulary word we're going to have to be familiar with, not only in this lesson, but this unit. It's the distance from one end of the circle to the other end of the circle, but it has to go through the center. So it's like this red line right here. This would be considered a diameter. It's not the only diameter. For example, you could go from this edge of the circle through the center to this other edge as well. And that would be considered the diameter as well. The nice thing about the diameter of one circle is that it will not change, because the distance from one end of the circle through the center to the other end of a circle will always be the same. But for me, this red line here is my diameter. Okay, so that's the red line. If we wanted what we call radius, that's the distance from the center of a circle to any of the edges of the circle. So if I went from my center to the edge here, or maybe even down here, that's considered what we call radius. But it can be anywhere. And just like the diameter being the same for any particular circle, the radius is the same for any particular circle as well. So I'll have to make my own circle or radius here on this one. So for my center, I have this purple line now. Again, we call that radius. It is the radius of a circle, okay? Now you may be drawing these in different places, and that's fine. Last thing, like we've seen on the objective, is the circumference. So the circumference is kind of like the perimeter of a circle. It's just the distance around the circle. Doesn't matter where you start, it's the distance around the circle, okay? So circumference for me, I'll put this in blue. It's going all the way around the circle here. This is circumference. And the good news about this is there's not ever any type of spelling test on this kind of stuff. So you don't have to worry about that if you were. But the circumference is just another way to say perimeter. We did perimeter in the last unit for rectangles. Now we're looking at perimeter of circles, which is not quite the same as we would for rectangles, right? Rectangles just length times width. Circumference for circles has its own formula, which we will have to know. Pi, which is the Greek letter P. And yeah, that's what it looks like in Greek. Not that I really think you guys care, but there it is. All right. Sometimes if you're doing this by hand, some people just do kind of two straight lines like this and then a little Enye thing over the top of them. Whatever, it doesn't really matter. Some people like to be a little bit more exact. They make that first one a little curvy. You know, if you really want to go into calligraphy here, then you can make it as pretty as you want. I really don't give a crap, okay? So, pi is the exact ratio of circumference to diameter of any circle. So, if you take any circle, no matter how big or small, no matter if it's the size of the galaxy or Saturn's rings, they could be large like that, or they could be extraordinarily tiny. Like the size of a small atom or particle. If you take the circumference of those circles, no matter how big or small, and divide it by their corresponding diameter, you get the ratio pi. Pi, I like to just see it as 3.14. Now there are more decimals to that. So why do I like to see it with only 2 decimal places? It's because those are the only 2 that I have memorized. Well, why don't I memorize more? It's because the calculator knows the rest. So you can find the pi button on the calculator, and actually it looks just like the pi symbol. If you look one button to the left of 7, and then 2 more buttons up from there, in the very left column, you'll see the pi button. If you push pi on the calculator and push enter, it will say, you wanted pi? Here's some pi for you, okay? Now, if you wanted the decimal, which is usually what we're going to be seeing, so I already have pi written on my calculator. All I've got to do is push the double arrow button that's immediately above the enter button. When I do, my calculator now shows me a lot more decimal places than I have memorized. 3.14, 159er, 2654. Now there's more decimal places to this, but that's as many as the calculator will show me right now, okay? So we don't actually need more than this like we've seen in the objective. We will only need either the tenths or the hundredths place value. So yeah, we may see some thousandths because we are going to be using the pi button. In the past, we've said just use 3.14. No, we have a pi button. We're going to use it. Here's our circumference formula. So this was our second objective, right? If we have the radius, can we find the circumference? Now, part of the objective said, well, if we have the diameter, can we find the circumference? If we go back, yeah, we can see this diagram here. We may have noticed in the explanations, and I didn't explicitly say this, but you can see that the radius is from the center to the edge of the circle, where the diameter goes from one edge through the center to the other edge, meaning that the radius in relationship to the diameter is like the diameter, but cut in half. And yeah, there's lots of different ways to show this. I'll just multiply by 1/2. Some people make it over 2 or divide by 2, and that's the same thing, okay? If for some reason you wanted the diameter, but all you had was the radius, then what you do is you take the radius right? Because the radius is from the center to the edge, but the diameter is from the edge to the center to the other edge. You'd have to double the radius. So radius is half the diameter. On the other side of that, the diameter is double the radius, okay? So, in other words, in this formula, 2 times the radius, well, that is also the diameter. And again, you're going to need to know this because on the assignment, they're going to say, well, here's a circumference formula, but we're going to give you the diameter. Well, just take the diameter and multiply it by pi. Okay, but if they give you radius, you can just use the formula, circumference. Well, circumference, it's pretty much the same formula, it's just changed into radius instead of diameter. Just take 2 and multiply it by the radius, and then multiply that by pi, okay? So, there is our circumference formulas if we are given radius or diameter. But for the most part, we're going to be seeing this as 2 times radius times pi. So here we have the radius directly. The radius of the circle is 9. I have the formula. And I'm going to replace the radius here with 9. So if I want the circumference, which I do, that's what they said here, find the circumference. My circumference will be the same as 2 times the radius, which is 9. And then I will multiply that by pi. Now here we have to remember the question says we're going to round this to the nearest tenth and in terms of pi, which means on this problem we're actually looking for 2 answers. Now they're going to be the same answer, they're just going to be shown in different ways. So in my calculator, I just type this in, 2 times 9 times pi, and the calculator gives me my first answer in terms of pi. Okay, the calculator says, all right, you want the circumference, you did 2 times 9 times pi. On my calculator, it says 18 pi. Now, I will label that. But this one is in terms of pi. That's this one right here, okay? But it also says that we want this rounded to the nearest tenth, right? So this is where I go to the bottom right of my calculator. Just immediately above the enter button is the double arrow button. And I push it. So I push it, and my calculator says 56, I do better 6 than that, 56.5488, 86, 5.486, 6776, which means it goes on forever, okay? Now, I actually have given myself too many numbers. I actually don't need the 6 right here because, well, I don't really need the 8 either, because it says to round to the nearest tenth. The tenth place value is the 5 in this case. So again, I can ignore everything to the right of the hundredths. But I look to the right here and I see a 4. 4 is less than 5, which means the 5 here in the tenth place value just stays the same. And now I can change this 4 into a phantom 0. Well, last thing I need to do here is just put a label on my answer here, 56.5 feet. And now I have both answers. In orange, I have my answer rounded to the nearest tenth. And in green, I have my answer, which is more exact, by the way, but it's 18 pi in terms of pi. All right, for this one, it's going to give me the diameter. The diameter of the circle is 4 centimeters, okay? But remember, our formula is in the form of radius, or it's in terms of radius. So this means that I need to change my diameter to radius. Well, the radius is the same as taking the diameter. I'll show this a little different, but it's just divided by 2. And over here, they've given me the diameter at 4 centimeters, right? So for my radius, I'll take my diameter, which is 4. I divide it by 2, and this will give me my radius in centimeters. 4 divided by 2 is 2. So my radius is 2 centimeters. So with this radius, now I go into my circumference formula, and I say my radius is 2 centimeters. Okay, so going back to the formula, circumference, going to equal 2 times the radius, so 2 times 2, and then times pi. Now again, when I put this into the calculator, it's going to give me the answer in terms of pi. So I type in 2 times pi, and it gives me again, the answer in terms of pi is just the calculator shows 4 pi. And I won't forget to label this, it's in centimeters. But again, this is one of our answers. Now, in order to write this to the nearest tenth, so my calculator got 4 pi, I push the double arrow button above the enter button, and then it gives me the new circumference as a decimal 12.56637061. But again, I really only need to round to the nearest tenth, so I don't even need the hundredths or thousandths place value. I do need the hundredths. So I looked at my tenths place value. It's a 5. And I look immediately to its right. Well, it's a 6, which is, it is 5 or more. 6 is 5 or more. So that means I need to add 1 to the tenths place value, okay? So I go in here, I take my tenths, where the 5 is, and this means I need to add 1 there. So 5 plus 1 would be 6. Again, the 6 right here, now I turn that into a 0 or phantom 0. So I now have 12.6. Well, again, in centimeters though. Okay, so there's my rounded answer to the nearest tenth. 4 pi centimeters, that's my answer in terms of pi. If by chance it does ask for answers in terms of pi on the assignment, which it probably will do, it should either have you type in the word pi, P-I, or it should have a button for you to push to enter pi, the symbol. The circumference of a circle is 17 pi inches. And this is already in terms of pi, so that's nice. But what we want to do here is find the radius in inches. But again, it's given us this circumference here as 17 pi. So instead of having a radius, now I have circumference as 17 pi. So this would equal 2 times the radius times pi. And I'll just use r for radius. This now becomes an equation that I need to solve using principles of equality. Now I can do it in 2 principles of equality, but I could do it once. And maybe I'll show it twice just so you can see how to do it one time and then how to do it 2 times with 2 principles of equality, okay? So for this one, I'm gonna say, look, I don't want the 2 with r, or the coefficient of r. I also don't want the pi, but I'll get rid of the 2 first. How do I do that? Well, I'll divide it by 2. Well, if I do it to one side, I'll have to do it to the other side. Now I'm gonna keep this as a fraction, so even though the calculator is gonna give me 8.5 rather, I'm just gonna keep this as a fraction as 17 halves pi. Which now equals, see, the 2 divided by 2 is a 1, so I got radius times pi. Well, I don't want the pi with the radius either, I just want radius. So how do I get rid of the pi? Which actually sounds bad because I do like pi. But I'll have to divide by pi. That'll make it a phantom 1. But if I do it to one side, still principle of equality, so I got to do it to the other side as well. Well, pi divided by pi is 1. Same with it is over here. So it really just makes those phantom 1 away. And so I'm left with my radius is 17 halves equal my radius. Of course, we know that that was in inches, so I will label it inches. Now that is something you should expect whenever you see pi as part of your circumference, and you're solving either for radius or diameter, by the way, is that the pi's are gonna essentially, I try not to say cancel out, some students like to say it that way, but it makes it go away, it undoes it, all right? And that happens because you got pi's on both sides, like we saw in the original equation up here. Now, like I said, you could do this in one step as well. And if you were to do it that way, with one principle of equality, what we do is I'm going to show the division differently here. Is I would divide by 2 to make this a phantom 1, but if I do it to one side, I got to do it the other side. But I can do it with pi as well, even though it's kind of far away from the 2. So then I can show, well, look here, I'm going to divide by pi. Now these pi's make a phantom 1, same with these ones. I already made a phantom 1 out of the 2's, which allows me just to take my radius and drop it. So then I get the radius, which is still 17 over 2. Well, inches. Same answer, different method, and so you can do both principles of equality here one time, or you can do it 2 times, doesn't matter. The circumference of a circle is 5 pi meters, find its diameter. Okay, well, we can start by finding the radius, which isn't too bad. So the circumference, they've said, is 5 pi, so I'm going to replace the circumference with the value they've given us, 5 pi. So this would be equal to 2 times the radius. So 2 times r times pi. Now, for those of you that remember, you could have used diameter here, but I want to keep it the same so we don't have to memorize so many stinking formulas, which there are a lot in this unit. So, at this point, I'll do this in 2 principles of equality, although like I've shown, you could do it 1. Okay, so I'm going to divide by 2 first. I'll say, look, divide by 2 here, divide by 2 here, right? So then I have 5 halves pi. 5 pi halves, doesn't matter. This becomes a phantom 1, and then I'm left with my radius times the pi. Now, I want to get rid of the pi. So, to get rid of the pi, another principle of equality here, I have to divide pi by pi. But if I do it to one side, I'll have to do it to the other side. Now, I'm showing it only dividing by pi there. That's for convenience because pi divided by pi is 1. Anything divided by itself is 1, including pi. And since these are 1s, that means I can make them phantom 1s. I really don't have to look at them anymore. So my radius ends up being just the fraction 5 halves. Now this would be good if we wanted radius, but we wanted diameter. Well, if I want diameter, which I do, then I would have to take the radius, and I'd have to multiply it by 2. Well, I know my radius. It's a fraction. That's okay. But my radius is showing at 5 halves. Okay, so 2 times 5 halves. You can put that in the calculator if you need, but it will give me the diameter of 5 meters. And that's the value we actually want on this one. Now, like I said, from the formulas we saw earlier, you could have used the diameter formula. I really don't care which one you use. I don't really recommend doing it this way, but I'm going to show it because some of you, I think, prefer to do it. Some of you understood that it's diameter times pi. So here, where they gave us the circumference, you could have said, well, I know my circumference is 5 pi. Then to find the diameter, all you'd need to do with the principle of equality is divide both sides by pi. Well, then you got a pi divided by pi on both sides, which become phantom 1s, and you get 5 equals the diameter. Of course, 5 meters. So we get the same answer either way. I still recommend using the radius until we get more used to this, and then trying to use this diameter stuff, but I think some of you guys may have it down. And if that's you, that's fine. But we may see a problem like this where it gives us a nice decimal for the circumference. We do want the diameter on this one. So I'm going to use this formula, and the circumference, pretty ugly decimal, no problem. We can still work with 12.56637. Usually they use these, or when they do use them, we get at least a decent value to use with radius or diameter. So 2 times radius times pi is this pretty ugly decimal, but the process still remains the same. I'll still take the 2 and divide it on both sides. Okay, so on my calculator, I can't do that in my head. If you can, that's pretty sweet, but I can't. 12.56637 divided by 2. Enter, and my calculator gives me 6.283185. And this now equals radius times pi. Right, because the 2 divided by 2, that became a phantom 1, just like we wanted. But now I want just the radius, which will help me to get the diameter. So I'll have to divide pi by pi as well. But if I do it to one side, I'll have to do it to the other side as well. So this will leave me with just the radius, which equals 6.283185 divided by, I'm using the pi button here, and I get 1.999999902. And I feel pretty comfortable just rounding this. I don't know about you, but I feel comfortable just rounding this to 2 centimeters. Okay, well, that's just my radius, but we want diameter in this one. So That's where we take the radius and multiply it by 2. So my radius, being really about 2 centimeters, tells me my diameter is 4 centimeters. And that's the value I actually want. Yeah, so the diameter and the radius came out pretty good after rounding anyways. Which is usually what happens when they give us decimal values like this. Eventually the radius and diameter usually won't need to be rounded. We did round the radius, but you could have used 1.9 and some change, and eventually you still would have essentially gotten through. All right, so we saw all 3 objectives. We should be able to round to at least the tenths and the hundredths, if not more place values than that. But we should be able to find the circumference if we're given the radius or the diameter. But if they give us radius or diameter, we should be able to find the circumference of any circle as well.